We want to determine the antiderivative or evaluate the indefinite integral using integration by parts. Now this problem is actually a little bit unique because it can be done using some fancy U substitution, which I believe I did show in a previous video, but I also want to show how to use integration by parts to evaluate this indefinite integral. So here's the integration by parts formula, and the idea here is to let u equal part of the integral, and then let dv equal the other part. And then we'll differentiate u to determine differential u, and we'll integrate dv to determine v. This one's a little tricky because we want to select u so that differential u is simpler than u, and we also want to select dv so that it's easy to integrate. And x as well as the square root of x plus 2, but x and the square root of x plus 2 can both be differentiated or integrated. But before we set this up, let's go ahead and rewrite this as the integral of x times the quantity x plus 2 to the 1/2 power dx. So notice how if this x wasn't here, we could actually integrate this using u substitution. So if we let u equal x, notice that differential u would just be 1 dx. So we'll try that first. We'll let u equal x, therefore differential u would just be 1 dx or dx. So if this is u, that means dv must be the quantity x plus 2 to the 1/2 dx. So we have to integrate this to determine v. So let's take a closer look at the integral of the quantity x plus 2 to the 1/2 power dx. It looks like it's going to require u substitution where u would be equal to x plus 2, but notice how differential u is just 1 dx or dx. So we could write this as u to the 1/2, and dx is just equal to du. So the antiderivative would be u to the 3/2 divided by 3/2, or the quantity x plus 2 to the 3/2 divided by 3/2 plus c, which is the same as 2/3 times the quantity x plus 2 to the 3/2 plus c. But of course for v, we'll leave the c off until the very end. So v is equal to 2/3 times the quantity x plus 2 to the 3/2. And now we can apply the integration by parts formula. The original integral is equal to u times v. Well, here's u and here's v, so we'll have 2/3 x times the quantity x plus 2 to the 3/2 minus the integral of v du. Well, here's v and here's du, so we'll have 2/3 times the integral of the quantity x plus 2 to the 3/2 dx. Notice how this integral here does not have that extra factor of x that was causing a problem, so this integral is much easier to evaluate than the original. So we'll have 2/3 x times the quantity x plus 2 to the 3/2 minus 2/3 times the antiderivative of the quantity x plus 2 to the 3/2. And again, if we let u equal x plus 2, du is still dx. So we can think of this as u to the 3/2 du. So we'll add 1 to the exponent. 3/2 plus 1 would be 5/2 divided by 5/2, which is the same as 2/5 times the quantity x plus 2 to the 5/2 power. And of course, plus c. Let's go ahead and clean this up. We have 2/3 x times the quantity x plus 2 to the 3/2. This is going to be minus 4/15 times the quantity x plus 2 to the 5/2 plus c. I think this is a fairly challenging one because it is fairly difficult to determine what we should let u equal and what we should let dv equal. But here's our antiderivative. In the next video, we'll take a look at applying the integration by parts twice to evaluate an integral. I hope this was helpful.